Hello, so we will now be talking about Chapter 9 on water and minerals. So here are some of the objectives for this chapter and video. We'll talk about important roles of water in the body and symptoms of dehydration. We'll talk about how the brain and kidney will work together in promoting fluid balance. We'll talk about the pros and cons of drinking bottled water, differentiate between hard and soft water, talk about food sources with calcium and their absorption, the amount of calcium absorbed from different types of foods. We'll talk about risk factors of osteoporosis and how to reduce the risk of osteoporosis. We'll talk about the organs involved in regulating blood calcium. So you'll see there's a big focus on calcium. We'll talk about other minerals, including phosphorus, magnesium, sodium, potassium, iodine, iron, zinc, selenium, and chromium. And we'll also talk about symptoms of deficiency. So you can see here, there's a list of the minerals and major categories as it relates to the roles of minerals in the body. So we see that minerals do many important things. We see that they're involved in regulating water and electrolyte balance. They're antioxidant minerals, just like antioxidant vitamins. We see some involved in the contraction and relaxation of muscles, some involved in regulating nerve impulses, blood formation and blood clotting, just like we saw some vitamins involved in this role, some involved in growth and development, blood health, and also cell metabolism, or otherwise known as energy metabolism, which we saw with the vitamins. So, number of roles of minerals, just like with vitamins. We'll first talk about water. So water is very, very important for metabolism. Many reactions involved in metabolism are water dependent. And so it is important that we have a lot of water in our body. So water makes up about 60% of a person's weight. That's about 80 pounds of a 130-pound person. So we consist of a lot of water. There are many important roles of water in the body. It's a universal solvent, so it can dissolve amino acids, glucose, minerals. So for this reason, water is very helpful and useful and involved in many reactions in the body. Fatty acids can also travel in water, packaged as lipoproteins. Water is the body's cleansing agent. Small molecules dissolve in watery blood and must be removed. Kidneys filter the waste from the blood. We also see that water acts as a lubricant or a cushion. It lubricates the digestive tract, the respiratory tract, among other areas in the body. It also helps to maintain body temperature. Heat is produced by energy metabolism and can build up. The body routes the blood supply through capillaries. The skin secretes sweat and the water evaporates. So when we sweat, water is a huge component of this, and it helps us with the evaporation of sweat to cool off. You can see here what our weight is made of. So for a healthy man and woman, average 170 or 130 pounds. So we see what the weight is composed of. We see a lot of that is water. We see also protein, fat, minerals, and glycogen in our tissues. So we have our recommended intakes of water, adequate intake for total water versus fluid alone. So total water makes up the water found in foods that we consume as well as our fluid intake. So total water intake for women and men would be about 3 to 4 liters per day. For just fluid intake, however, it would be approximately 2 to 3 liters per day. We have a fluid balance, so it's very important that we have this balancing act between the intake of water and the amount that we excrete or that comes out. So water intake is composed mostly of the fluid that we drink. However, we also see the water content from food and the water produced from metabolism. On average, we see this would be for a woman approximately 12 cups, and then that needs to be balanced with our output. and the output is largely coming from urine, also perspiration, so sweat loss, lung respiration, and then the amount coming out from our feces. So we don't want to have a positive water balance or a negative water balance. We want to have equal inputs and outputs for the most part. So this is how we regulate our fluid balance if we are in a condition where we lose fluids, become dehydrated. Our body has a way of counteracting that. There are a number of hormones involved with this process. One would be called antidiuretic hormone that comes from the posterior pituitary gland in the brain. We have another hormone called aldosterone, which is also involved in regulating fluid and also electrolytes. So we see first when our body fluids are depleted. So if we become dehydrated, this actually affects our blood volume. So our blood volume is decreased as we are dehydrated, and our body senses that. We see that receptors in the hypothalamus sense that the blood is becoming more concentrated. This signals to the posterior pituitary to release antidiuretic hormone, and that signals to the kidney to retain more water, so we don't excrete as much water, we reabsorb more water, and that helps to restore fluid balance. We have this also being affected by aldosterone, so the kidneys sense decreased blood flow, and also it senses an increased concentration of sodium, and as a result we have an increased synthesis of aldosterone from the adrenal cortex, and that increases the reabsorption of our minerals, namely sodium but also chloride, which results in increased water retention by the kidneys, also helping to restore fluid balance. So the main hormones involved in this process again are antidiuretic hormone coming from the posterior pituitary in the brain, and aldosterone coming from the adrenal cortex. Okay, so you see here the percent body weight loss in the condition of dehydration. So as our percent of body weight loss from fluid increases, we have more severe outcomes related to dehydration. Dehydration is typically defined as a 2% of body weight loss or greater. We see at this level we start experiencing a stronger level of thirst, loss of appetite, and as a percent body weight increases, more severe symptoms, moving from flushed skin to drowsiness, apathy, and nausea, to heat exhaustion, headache, labored breathing, muscle cramps, and increased risk of death. There's also a condition where individuals consume too much water, and this leads to a condition called hyponatremia or overhydration, where the proportion of fluid is higher than what is required for adequate sodium levels in the blood. So it again is overhydration and sodium dilution of the blood, also called water intoxication, which is potentially fatal. This can be just as, if not more, dangerous than dehydration when it's characterized by dangerously low levels of blood sodium. So we see our water and electrolytes and involved in fluid and electrolyte balance, as well as acid-base balance. Keeping water where it is needed in the body is very important. For example, when someone has extreme vomiting or diarrhea, fluid leaves the cell interior to restore fluid balance. The kidneys will then detect water loss and try to retain water that would otherwise be excreted. So this may also affect acid-base balance by disturbing the level of hydrogen, either lowering the pH, making it more acidic, or increasing the pH, making it more basic. The kidneys help to control or regulate our pH level. Lungs will also control the amount of CO2 that is released, which affects our acid-base balance. Minerals may act as buffers to maintain body fluids and the correct pH. We see key minerals including here sodium and potassium. So we see here differences between hard versus soft water. Hard water contains higher levels of calcium and magnesium, whereas soft water naturally only contains sodium. However, if too high, it may be unsuitable for drinking. Also, we see differences in bottled water versus tap water. Americans consume over 30 gallons of bottled water per capita per year. Most bottled water is treated with ozone, which does not impart a flavor to the water. However, the Environmental Protection Agency, the EPA, regulates and monitors public water supplies. The FDA regulates bottled water. So there's different levels of regulation or agencies regulating tap water versus bottled water. EPA regulates tap water. The FDA regulates bottled water. Fluoride is added to many water supplies to prevent dental caries. Plastic used to package bottled water creates a huge energy use. With recycling, that can help with reusing waste, and but also there are waste disposal concerns with excessive bottled water. Also, plastic has a shelf life over time. The chemicals that make up plastic break down and may leach into the liquid inside the bottled water container. So we see here a list of all the minerals contained in the human body. They're classified by major minerals and trace minerals, and this is as it relates to grams of the minerals in the human body. So just looking at this, what is going to be the highest mineral in the body we see is calcium. Why is that? We see calcium is stored and largely composes the bones in our body. Phosphorus is also a part of a component of bone with calcium. They are found together in hydroxyapatite, which is one of the primary components of bone. We see other major minerals being sodium and potassium, chloride, sulfur, and magnesium. The trace minerals, some of them here listed: iron, manganese, copper, and iodide. You can see the 5 major food groups from my plate that we've talked about: grains, vegetables, fruits, dairy, and protein, and a list of minerals most commonly found in those food groups. So just looking at this diagram or this image, what food groups contain the most minerals? We see grains will contain many minerals, some being fortified, some being naturally found in the foods: iron, zinc, copper, selenium, magnesium. Calcium may be fortified in some products. Protein foods are also going to contain a lot of minerals: iron, zinc, copper, potassium, phosphorus, magnesium, selenium. Dairy will also contain calcium, phosphorus, zinc, and magnesium. So first we'll talk about calcium. There is a big focus of calcium in this chapter. It is the most abundant mineral in the body. It's found in bone and teeth. We find calcium in our body fluids. It's very important to maintain our serum or our blood calcium levels within a very tight range. That calcium plays a very key and important role in nerve conduction and muscle contraction. So nerve conduction and muscle contraction are very important functions of calcium. It's very important to keep our blood calcium levels tightly controlled so we have adequate functioning of those processes. We have our calcium balance and our calcium storage. This calcium bank is actually our bones. When our blood calcium is low, this is not favorable, but it is important. If our blood calcium is low, we can actually demineralize or break down bone to free up calcium to re-enter the blood. And we saw that happening when we talked about vitamin D in the minerals chapter. So there are a lot of foods that will be rich in calcium, primarily dairy foods such as milk, yogurt, and cheese. There are also fortified foods such as soy milk, almond milk, other milk products could be fortified with calcium as well. We have plant-based sources of calcium that we'll also review. The percent absorption is going to vary based on the food. So some of the plant-based foods, even if they're rich in calcium, may contain binders. These are binders that will affect the absorption of calcium and will promote the excretion of calcium when consumed. So spinach, rhubarb, Swiss chard, these may be rich in calcium, but the calcium will not be available for absorption because of the binders. One common binder for calcium is called oxalic acid. We have dairy foods, which are also rich in calcium. About 30% of the calcium from those foods are absorbed. And then we have other plant-based sources here, such as bok choy, broccoli, cauliflower, cabbage, kale, etc. The percent absorption is going to be higher than 30%. So on average, about 30% of calcium that we consume is absorbed. Vitamin D helps make the vitamin D helps to make the proteins needed to absorb calcium. So it is important that we have adequate calcium and vitamin D to optimize absorption. The calcium absorption is reduced when the level of stomach acid is lower, when vitamin D is lower, in a high fiber diet, or with binders such as phytates and oxalates. It's important to have adequate calcium balance. High or low blood calcium can affect the response from the intestines, bones, and kidneys. So we saw in the vitamin chapter and the vitamin video, when blood calcium is low, it elicits a response at the level of the intestine, the bone, and the kidney. So when blood calcium is low, the intestine will increase the absorption. So vitamin D helps with this response to increase calcium absorption at the intestine. We have increased demineralization of bone to free up calcium to enter the blood from the bone. And at the kidney, it increases reabsorption of calcium or reduces its excretion so that we can increase blood calcium levels. It's interesting that bone mineral density, so the strength of our bones, that changes, and the response of our diet and our environment actually doesn't affect a bone until about a year later. So if someone has a chronic deficient diet in calcium or vitamin D, their bone density won't be affected right away. It may not show up or be affected until 6 months to a year later, and that is because the bone remodeling process and the bone remodeling cycle can take up to 3 to 6 months, and so our bone density is not affected for a while. We see bone loss will occur with age, and so we have the process of bone mineral accumulation during childhood and adolescence. At about age 20, we reach what is called our peak bone mass, and so we have the highest bone density, and that is due to a very rapid level of accumulation between ages 10 and 20. Bone mass will then plateau for about 30 years, and then it will slightly decline between ages 40 and 50, where we have bone loss occurring. So this is the stages of bone mineral accumulation. Then we have a plateau, and then we have loss of bone later in life. Those that have a low peak bone mass, so they don't accrue or accumulate as much bone during the high school years, or those that have accelerated bone loss later in life, may be at risk for osteoporosis. We see here the development of osteoporosis is the condition of low bone mineral density. Low bone mineral density, which increases risk of osteoporotic fracture. This usually occurs at the hip or the lumbar spine. We have two different types of bone. One type of bone is called trabecular bone, which is soft, spongy bone. It is more porous. And then we have cortical bone that is more dense. You can see here in this bone structure that the cortical bone lies on the outside. So this dense cortical bone is on the outer portion of bone, whereas the soft, more spongy, and it's also called more metabolically active because it's innervated and it has a higher blood supply. The trabecular bone is on the more inner portion of the bone. So we see the trabecular bone and the cortical bone. Trabecular bone, which is again more metabolically active, is the type of bone that is most affected when blood calcium is low. So when you first will decline in bone mass, when you first demineralize bone when calcium is low, that will initially affect the trabecular bone. You can see normal trabecular bone. Here there is adequate density and connections between bone surfaces. With osteoporotic trabecular bone, there are more openings and it's less dense. With that, you have more vulnerability and increased risk of fracture. With osteoporosis, it can lead to a condition called kyphosis, or a loss of height. We also see something called the dowager's hump, which is the bent posture of older adults as they grow shorter. So that hump in the back will be typically resulting from potential fractures of the vertebrae. These are called compression fractures, where the vertebral bones actually compress, which leads to a loss of height and this dowager's hump. How do you measure bone density? So this is what's called a DEXA scan. That is a machine used to measure the strength or the density of your bones. The clinical sites that are measured typically are the hip, the lumbar spine, and the full body. Is what is used to measure bone mineral density. From there, you can actually come up with a diagnosis of being osteoporotic or not. There are drug therapies that can be used to treat osteoporosis. However, diet is also important and plays a role. We see here food sources of calcium. So foods rich in calcium would be dairy foods. We see tofu also is higher in calcium, fortified orange juice, spinach. However, we saw that spinach has the oxalates that decrease the bioavailability, also fortified cereals. And then we have the RDA for calcium as 1,000 milligrams per day for adult men and women. Phosphorus, as we saw in the previous diagram, is the second most abundant mineral in the body. It's found with calcium in the compound called hydroxyapatite, which is a primary component of bone. We see primary roles of phosphorus in the body, so it's involved with the growth. It's a key component of ATP. It's essential for either activating or deactivating enzymes involved in our metabolic processes. It's a component of phospholipids, which make up the phospholipid bilayer of our cell membranes, and it's a primarily negatively charged ion in the intracellular fluid. Deficiency of phosphorus is not common. There's a lot of phosphorus found in various foods. However, the symptom of deficiency is weakness, poor appetite. High calcium supplements may potentially bind phosphorus, decreasing its availability. We see the RDA for phosphorus is 700 milligrams per day in adult men and women. We see foods high in phosphorus being also dairy foods like calcium, some foods rich in protein such as salmon and beans and nuts, and some grains including cereals, oats, and trail mix containing nuts. Magnesium works with calcium as a component of bone. Kidneys help to preserve magnesium in the body. It acts in all cells of the muscle, liver, heart, and other soft tissues. It helps to relax muscles after contraction. Deficiency of magnesium is not likely, but it can occur in certain conditions. The symptoms would be vomiting, diarrhea, weakness, muscle pain, disorientation. It may help disrupt the hormonal regulation of blood calcium, and deficiency of magnesium may occur with kidney disorder, alcoholism, or excessive magnesium losses from vomiting and diarrhea. In addition, we see that magnesium actually works as a cofactor for many of the processes of energy metabolism in the body. It helps to stabilize ATP in reactions that are ATP dependent. So it works with our vitamins and that are involved in energy metabolism. Okay, so we see the RDA for magnesium is 400 milligrams per day in adult men and 310 milligrams per day in adult women. We have foods rich in magnesium being vegetables. We see spinach is a rich source. We have Raisin Bran cereal. We have some dairy foods, also nuts, beans, chicken, and some grains being foods rich in magnesium. Next, we see sodium. So we have sodium with sodium making up with chloride, sodium chloride. 1 teaspoon of salt contains 2,400 milligrams of sodium. We can relate that to the adequate intake level of sodium being 1,500 milligrams per day. So we would want to have less than 1 teaspoon of salt in our foods per day. We see that sodium plays a major role in fluid and electrolyte balance, acid-base balance. It's involved in regulating nerve impulses, so it plays many important roles in the body. Deficiency is not a concern typically in the US because of the high availability of sodium in our foods, especially processed foods. However, some situations may elicit or promote low sodium levels, which would be the condition called hyponatremia, low blood sodium, which can be very dangerous. And we saw that when we discussed water. Where do we get sodium? So we see that most of the sodium that we consume is sodium already found in our food, especially processed foods. So adding sodium with salt, like a table salt with a salt shaker, doesn't make up most of the sodium that we consume. Most of the sodium that we get is actually already contained in the foods that we consume. Processed foods, we think of deli meat, we think of soups, we think of sauces, dressings, marinades. These are all going to be very, very rich in sodium. So very little is actually added when we cook at home or added to foods when we are at the table already. There is a small amount present naturally in foods. But really, to limit our sodium intakes, we would want to not necessarily reduce the amount that we add to cooking at home. We would want to reduce the amount of processed foods that would be already rich in sodium. High intakes of sodium are linked to high blood pressure, which is called hypertension. So we want to, those that may be more prone to hypertension, especially who are salt sensitive, those that are salt sensitive may be more at risk for hypertension linked with sodium intake, may want to follow a low sodium diet. One such diet is called the DASH diet, which is linked to lower intake of processed foods, higher intakes of whole fruits, vegetables, whole grains, beans, legumes, and it's other overall healthy diet with, again, plant-based foods, whole fruits, vegetables, whole grains, beans, legumes, which is going to be naturally containing a lot of vitamins and minerals anyway. So this would be a diet specifically focused on lowering intakes of sodium. We see the adequate intake for most individuals would be 1,500 milligrams per day. The daily value is 2,400 milligrams per day. This is going to be much lower what we are recommended to consume compared to what we actually consume. So the average intake of sodium in the US is 2,300 milligrams per day to 4,700 milligrams per day. This is significantly higher than what is recommended. So we, on average, consume more than we need. This is largely due to our high intakes of processed foods. We talked about those people who are salt sensitive, who in response to consuming higher intakes of sodium may develop high blood pressure or hypertension. So 10 to 15% of individuals in the US are sodium sensitive. Food sources of sodium, so we said soups, sauces, processed foods such as pepperonis, cheese, deli meat are all going to be foods higher in sodium. Canned foods, you see even like healthy canned foods are going to be higher in sodium. So for example, if you have beans, you want to reduce the sodium content, you can actually drain and rinse the beans to reduce the sodium that you would be consuming. Cottage cheese is another food that is also going to be rich in sodium. So many foods, processed foods, sauces, soups, processed meats are going to be high in sodium. Potassium works with sodium to regulate fluid balance and electrolyte balance. We see here it's involved in nerve impulse transmission. It's involved in the regulation of heartbeat. So in the US, opposite to sodium, potassium intake is much lower than recommended. We get potassium from whole fruits, vegetables, whole grains, beans, legumes. And so we have in the US lower intakes of those foods. We have higher intakes of processed foods. And so because we have lower intakes of whole fruits, vegetables, whole grains, beans, legumes, our overall intake of potassium is lower. That is in part why we see the new food label actually includes potassium as a required nutrient to be reported, because overall our intakes are low. We want to work on increasing intakes of potassium with these nutritious foods. We see the recommended intake level of potassium. The AI for potassium is 4,700 milligrams per day. Our average intake in the US is much lower than this, and so we want to be consuming more fresh fruits, vegetables, whole grains, beans, legumes to increase our intakes of potassium. Other foods rich in potassium, so coconut water is actually a very rich source of potassium. Also, avocados are going to be very high in potassium. All right, so now we'll look at chloride and sulfate. So chloride is a electrolyte mineral involved also with fluid balance. It is a component of hydrochloric acid, which is involved in the digestion of proteins. It helps with breaking down our foods in the stomach. The principal food source of chloride is table salt. So we saw with sodium, we have sodium chloride, which is table salt. So we see sulfates. So these are needed for getting sulfur, which is used in part to synthesize our amino acids. Next, we'll talk about the trace minerals. So we have a list of trace minerals starting with iron. Iron has two proteins that it's involved in, hemoglobin and myoglobin. Hemoglobin is the oxygen-carrying protein of the blood. Myoglobin is the oxygen-holding protein of the muscle. The liver packs iron from the bone marrow into new red blood cells. When red blood cells die, the spleen and liver break them down. saving them for recycling and sending it back to the bone marrow for reuse. Humans lose small amounts of iron from the gastrointestinal tract, skin, and hair and nails. Bleeding will produce significant loss of iron. Free iron generates free radicals. Iron must therefore be transported in a protein called transferrin and stored attached to proteins. So it is not favorable to have free iron circulating, so it has to circulate attached to a protein or stored with a protein. The body cells needs oxygen during energy metabolism. Iron in hemoglobin is involved with shuttling oxygen to tissues, so it's very important in carrying oxygen. It's also involved in making new cells, in making amino acids, hormones, and neurotransmitters. There are some proteins involved in the electron transport chain, which is needed to make ATP, which are also iron dependent. Enhancers of iron absorption, and this would be the non-heme iron. We have iron coming from animal sources, which would be heme iron. We have iron coming from plant sources, which is non-heme iron. So heme iron coming from animal sources is absorbed more readily. It's more bioavailable. Iron coming from plant sources is less available. So these non-heme iron would need these enhancers or help with the enhancers to absorption. So vitamin C is a factor that increases the iron absorption. So tomatoes contain vitamin C. So you would have some non-heme iron in spaghetti noodles. If you have vitamin C from the marinara sauce, the tomatoes in the marinara sauce, that would help with the absorption of the non-heme iron. Meat, fish, and poultry, so meat protein can also help to increase the absorption of non-heme iron. Inhibitors of iron absorption would be tannins found in teas, oxalates, phytates, so these would be some binders, and also high doses of zinc, calcium, or copper, so these other minerals may limit the absorption of non-heme iron. We have iron deficiency, so the most common deficiency symptom or condition is called anemia. And there are different stages in the development of anemia. Stage 1, we see that iron stores become depleted, but there is no physiological impairment. Stage 2, the amount of iron that we transport in transferrin is decreased. There is some physiological impairment. Heme production is decreased, and the activity of enzymes that require iron as a cofactor are limited. So that's stage 2 of deficiency. And stage 3 of iron deficiency anemia, we have small red blood cells called microcytic red blood cells. They are pale, which it's called hypochromic. When they are pale, the red blood cells are reduced in number, and the oxygen carrying capacity of the red blood cells declines. And this is going to be the most significant stage of microcytic hypochromic anemia. Anemia is then linked to symptoms of fatigue, mental impairment, impaired physical work capacity, and productivity. In kids, they can become restless, irritable, unwilling to work or play, have reduced attention spans. It can lead to a condition called pica. So if you heard of this before, pica is a craving for intake of non-food items such as ice, chalk, soil, and other foods that may contain iron. So the body is just trying to get iron from any source that it can. And so there are these key symptoms or signs of anemia. Groups most susceptible may be women of childbearing age, especially in the second trimester of pregnancy. Iron needs are increased. Infants and toddlers would have increased needs, and then adolescents. So women who are menstruating are going to be losing blood on a monthly basis, so their needs are going to be higher and would be more at risk. Too much iron or iron toxicity is also dangerous, where excess iron can build up in tissue, which is called hemochromatosis. In the US, when talking about deficiency, 2.4 million people have iron deficiency. 500,000 are diagnosed with iron deficiency anemia. Worldwide, iron deficiency is the most common nutrient deficiency. Parasitic infections of the digestive tract cause people to lose blood daily. So iron is a huge mineral of concern worldwide. We see food sources of iron. We see oysters, beans being rich sources. We see some vegetables, spinach, potatoes. We see raisins and prune juice containing iron, some grain foods. We see cereal here with the RDA for males being 8 milligrams per day and females being 18 milligrams per day. Next, we have zinc. So zinc plays a role in immunity, taste perception. It's significant in wound healing and growth. Zinc-containing proteins associated with DNA, which is needed for protein synthesis and cell division. This is critical to growth before and after birth. Too much zinc can affect iron status. They compete for binding sites on protein that transports these minerals. Vegetarians may also be at risk potentially of deficiency. We see foods rich in zinc are going to be animal sources, so it's important to get zinc from other food sources, grains, vegetables. Vegetarians that are not vegan can also get zinc from dairy products. We see the RDA for zinc being 11 milligrams per day for males and 8 milligrams per day for females. Next, we have selenium. Selenium is another mineral. It's involved in thyroid function. We're going to see that iodide is also involved in thyroid function, in the synthesis of thyroid hormones. There are selenium-dependent antioxidant enzymes, so selenium is an antioxidant mineral, and we may develop a toxicity of selenium with excessive supplementation. We'll see food sources of selenium. Brazil nuts is actually a very rich source of selenium, so that's not a food that we commonly eat, but those large nuts that you see in like a jar of mixed nuts, those are called hazelnuts or Brazil nuts. They are going to be one of the richest food sources of selenium. Some seafood sources, tuna, oysters, also rich in selenium, as well as some grains and plant-based foods. The RDA for men and women is 55 micrograms per day. So next we have iodide. So we see that selenium as well as iodide is involved with the function of our thyroid and in the synthesis of thyroid hormone. Deficiency of iodide will result in a goiter. Iodide in food varies with the amount in the soil. Seafood is a dependable source. Iodide adequacy is important for overall energy metabolism because the thyroid hormones are involved in energy metabolism. An enlargement of the thyroid gland is the goiter, which is the deficiency symptom and deficiency condition. And the reason being is we have our body is trying to make more of the thyroid synthesizing hormones to make more of the thyroid hormones, the active thyroid hormones, and in the process, the thyroid gland becomes enlarged. Iodine is part of the hormone thyroxine, which regulates metabolic rate, temperature, reproduction, growth, and heart function. Goiter is a painless condition, but it can lead to pressure on the trachea, causing difficulty breathing if the goiter and the thyroid gland gets too large. Iodide deficiency leads to sluggishness and weight gain. So it can lead to a condition called hypothyroidism, which causes a sluggishness, so feeling tired, and also weight gain. Excessive intakes of iodine can also enlarge the thyroid gland, just as deficiency. So either a deficiency of iodine or excessive intake can lead to a enlarged thyroid gland and goiter. So we have the fortification of iodide of salt, and this is occurring in many nations to prevent development of goiter. Iodine can prevent but not correct the goiter. We have food sources of iodine largely being table salt, which is fortified, but we see other food sources and the RDA being 150 micrograms per day. Next we have copper. So we see copper is a part of ceruloplasmin, which is a copper-containing protein found in the blood. It aids in the transport of iron. Copper is found in the highest concentrations in the liver, brain, heart, kidneys, and muscles. It's a cofactor of many enzymes. It also is involved in antioxidant defenses. There is an enzyme called superoxide dismutase, which helps with defending against free radicals. That is zinc and copper dependent. We see that copper is involved in the myelination of our neurons. It helps with the synthesis of neurotransmitters. It helps in the metabolism of lipoproteins, immune system function, and aids in blood clotting. We see good rich sources of copper. So foods rich in copper would be legumes, seeds, grains, cereals. The form actually found in multivitamins and multiminerals are not readily absorbed. The absorption of copper is highly variable due to it being prone to binders such as phytates and fiber. Also, high zinc and iron can interfere with the absorption of copper. Average intake in men and women is 1 milligram and 1.6 milligrams per day. We have the RDA being 900 micrograms per day, and we see foods rich in copper being some vegetables and fruits. We see liver also rich in copper, nuts, beans, and soy milk. So lastly, we'll talk about fluoride. 95% of fluoride is found in teeth and bones. It aids in preventing dental caries. Fluoride is incorporated into the tooth structure, which increases the strength and resistance to acid degradation from plaque. It stimulates the remineralization of the enamel of our teeth. It also provides an antibacterial effect. It increases protein synthesis as well in our bone building cells. There's a lower incidence of cavities seen in individuals of southwestern US in the 1900s, and it was found that there were high amounts of fluoride found in the water. So this led to the fluoridization of public water. Most fluoride comes from oral hygiene products. So there is a potential risk of toxicity for getting too much fluoride if a child would consume too much toothpaste containing fluoride. And so it's important to monitor children under 6 while they're brushing teeth so that they spit out their toothpaste. They don't swallow excessive amounts of toothpaste. We see a condition called fluorosis is stained and pitted teeth, which may be permanently damaged. Food sources of fluoride include fish and shellfish, such as clams, lobsters, crabs, shrimp, also tea and seaweed. The AI of fluoride for adults is 3.1 to 3.8 milligrams per day. However, we see the UL for young children being 1.3 to 2.2 milligrams per day. 10 milligrams per day for kids greater than 9 years of age. Typical fluoridated water contains about 1 milligram of fluoride per liter, or 0.25 milligrams per cup. Bottled water or reverse osmosis water purification will actually significantly restrict fluoride intake. Okay, so we will see some remaining trace minerals being chromium, molybdenum, and manganese. Manganese is going to be largely involved in energy metabolism. There is also an antioxidant role of manganese. There's a manganese-dependent superoxide dismutase in the mitochondria. We see molybdenum is involved in the metabolism of several amino acids. Chromium is an interesting mineral, trace mineral. We see it actually helps with insulin sensitivity, helps with the uptake of glucose into cells, which is relevant particularly for those at risk for insulin resistance or reduced insulin sensitivity, such as those with type 2 diabetes. And it also can help with the metabolism of lipids and proteins. So this sums up Chapter 9 on water and minerals. So please go back to your notes and review all of the content from Chapter 8 and Chapter 9 as you continue preparing for your quiz.